AP Cram, Calculus AB, Free Response Exam Review. Question 22, Implicit Differentiation and the second derivative. Consider the curve given by the equation y to the third minus xy is equivalent to 2. It can be shown that dy dx, or the first derivative, is equivalent to y over 3y squared minus x. What you are to do is evaluate the second derivative with respect to x, or d2y dx 2 or x squared, I'm not sure how to articulate this, at the point on the curve where x is equivalent to -1 and y is equivalent to 1. So this is our initial condition coordinate solution set, okay? So how would you go about this task? I'll give you a moment to think for those of you who are unsure, and for those of you who know what to do, just go ahead, hit pause, and write out your solution. All right. So in order to solve this problem, you're going to have to use implicit differentiation. That means taking the second derivative is simply just doing d dx of dy dx. So just differentiate this quotient or fraction, however you consider it in your mind, one more time. Okay, and in order to do that, you're going to have to use the chain rule for sure in this portion, and the quotient rule, or the quotient rule and the product rule are kind of the same thing. All right, so the second derivative with respect to x is going to be the term in the numerator, well, the derivative of the term in the numerator multiplied by the term in the denominator, okay, minus the term in the numerator multiplied by the derivative of the term in the denominator. And remember, I said you're going to have to use a chain rule for this. So the derivative, the way you differentiate this whole thing, the whole denominator with respect to x, is you take the derivative of 3y squared, which is going to give 6y, and then that's like the outer function, 3 something squared, okay? But then you also have to take the derivative of the inner function, and that's just simply going to give you dy dx, like you see here. So this is the chain rule in action. And then the derivative minus the derivative of x with respect to x, that's just going to give you 1, all right? All this is going to be over the term in the numerator squared. So this is generally what the quotient rule produces in differentiation. Okay, but we're also told that we need to evaluate the second derivative at the initial condition, or the solution set -1, 1. So all we simply have to do is plug in all these values into this ginormous monster. And as you can see, 1/4 has been substituted for dy dx. That's because if you plug in the solution set -1, 1 into dy dx, the derivative at that particular point is going to yield 1/4, okay? So that's where that comes from, so don't be too alarmed. This math is really simple. It's just a matter of being neat and combining like terms. So, and again, this dy dx was evaluated at the solution set 1, 1, -1, 1, that is. That's how we got a value of 1/4 to plug into our second derivative particular solution. So when we combine terms, we end up with 1 minus 1/2 over 16, which simplifies to 1 over 32. Okay? So this is this is the answer for the second derivative at the point -1, 1. All right? Okay.